First, let us quote the volume of the cylinder. For the volume, let me go for V. So V is equal to pi r square h, the volume of the cylinder. So in order for us to find the maximum possible volume, we want to first try to express V in terms of R or V in terms of H, which means that we need an equation that link R and H together. And I guess to do that, we will make use of the fact that the total surface area is given to us as 900. So if the total surface area is, let's say, A, so A is given to us as 900, and to get A, it is going to be 2 times of the area of the circle on top and below the cylinder. So it's going to be 2 pi r square plus the curved surface area of the cylinder, and that will be 2 pi r h. So this is equal to 900. And if you were to look at the expression for the volume, if I were to factorize out R, we will have a pi RH here, and there's a pi RH here. This makes it very convenient to replace this so that I can find this in terms of R. So if I were to do that, making pi RH the subject, this is going to be equal to 450 minus pi R squared. So now we can replace this pi RH by 450 minus pi r squared, which is equal to 450r minus pi r cubed. So now this is the expression for the volume. We are going to try to find the differentiation of V with respect to R. So dV dr. dV dr is going to be equal to 450 minus 3 pi r squared. And now, in order for us to find the maximum possible V, what we are going to do is to make use of the idea of stationary point by letting dV dr be equal to 0. So 450 minus 3 pi r squared, this is equal to 0. This gives me r to be equal to square root of 150 divided by pi, which I can re-express this as 5 square root of 6 over pi. So this is the value of r that causes V to be stationary. We want to test whether this value is also the value that causes V to be a maximum. So let's try to test for a maximum by using the second derivative test. So let's try to find d square V dr square. d square V dr square, differentiating this again, it is minus 6 pi r. So when r is equal to this 5 square root of 6 over pi. So when r is equal to this, let's see what is the value of d square V dr square. This will be minus 6 pi r. R will be 5 square root of 6 over pi. And this will lead us to a d square V dr square as minus 30 pi of square root of 6 over pi, which is less than 0, which means that now we know V is at its less than 0 maximum. So V is a maximum, which means that we can now find the maximum possible V. So from here, we can find the maximum possible V. And for the maximum possible V, we just need to sub this value of R back into here. So it is going to be 450 R, which is going to be this 5 square root of 6 over pi, and minus pi r cubed. So 5 square root of 6 over pi to the power of 3. And if you were to work this out, you will be getting a 1500 square root of 6 over pi.